All right, we're beginning section 6.1, and we're going to utilize all those factoring techniques we learned in chapter 5 on rational expressions. So let's define a rational expression. A rational expression is the fraction of two polynomials where the denominator is not 0. In algebra, a rational expression is also known as an algebraic fraction. Listed are some examples. You can see that all of these examples are fractions, and most of them have variables in the denominator. Now 6.1 is going to be over three things. First, we're going to look at rational functions, and we're going to revisit the idea of domain. A function is defined, remember, to be no repeated x values. For every x, there is only one y. Domain. We are going to work on finding the domain of this function. Remember, domain is all the x values that are allowed to go into the function. Well, since a rational function is a fraction, the part that we have to look at is the denominator. Because remember, the denominator of a fraction cannot go to 0, because that makes the whole fraction undefined. So the rational function, such as this example, and the example in 2, will be defined for values of x that do not make the denominator equal 0. So here's how we do this. We take our denominator, x minus 7, and we figure out, well, when is it 0? It is 0 when x equals 7. So we draw out a number line, we put 7 with an open circle, and we put arrows on both sides. The reason why is because 7 is the number that makes this denominator 0. Every other value on the number line is allowed. So our domain is the interval negative infinity up to 7, parentheses, because 7 cannot be included, union 7 to infinity. So that would be our domain. Our domain is saying, more simply, that x is allowed to be everything but 7. The reason why x can't be 7 is because 7 makes the denominator 0. Now problem 2 is a little bit more complicated because our denominator is a trinomial. So we set that trinomial equal to 0, and we find the answers to that trinomial by thinking of this as a quadratic equation. We learned in chapter 5 to solve a quadratic equation, we factor. So we're going to say x and x, 3 and 2, negative, positive. We're going to set each factor equal to 0. This one says x is 3, and this one says x is negative 2. Now remember, those are the values that make this trinomial 0. The trinomial is in the denominator, so the fraction would have a denominator of 0, thus being undefined. So these numbers are going to go on our number line with open circles because they cannot go into x. We can have every other value. So our domain is negative infinity to negative 2, union negative 2 to 3, because we have a gap, union 3 to infinity. In other words, x is not allowed to be negative 2 or 3, because negative 2 and 3 make this trinomial 0, making the denominator 0, which cannot happen for a fraction. The next part of 6.1 is going to be looking at a rational expression and learning how to simplify it. Well, if a rational expression is a fraction, we have to learn to put this fraction in lowest terms. So here's how we do that. First, you factor both the numerator and denominator completely. And then you cancel the common factors from the numerator and denominator. Said simply, factor first, cancel second. So we're going to look for GCF first and or any other technique allowed. So I see in the top x squared. So I'm going to factor out x squared, and I'm going to get 3x plus 1. The bottom, I see 3 goes into 18 and 6, and I see an x. So I'm going to take out 3x. 3 goes in, actually, I could take out 6. 6 goes into here 3 times. So 6 into here is 3x. 6 into itself is 1. Now I can cancel out anything they share. So 3x plus 1 is identical. And you get to x squared over 6x. And you might think you're finished. Well, if this is expanded, it's x times x over 6x. And now we see a shared x. So our answer is x over 6. That's our fraction in simplified form. Let's try again. Trinomial factoring here, I don't see any GCFs, so I'm going to factor the top using 2 sets of parentheses. I'm also going to factor the bottom using 2 sets of parentheses. So for 8, I'm going to try 4x and 2x. For 3, there's only one option, 3 and 1. My signs need to be different, so I'm going to put 3 here and 1 here. That would give me 12 on the outside and 2 on the inside. I want negative 10, so I'm going to do plus and minus. Now remember, your goal after factoring is to try to get something to cancel. So when I factor the denominator, probably one of these sets of parentheses is going to be down here. So since this was 4 and 2, I'm going to also use 4x and 2x. Something that's very, very wrong is to cancel before you ever factor. So you might think, hey, I'm going to cancel out these 8x squareds. You cannot cancel before you factor, so you must factor first. 9, I'm going to use 3 and 3. I get 12 and 6. I want negative 6, so I'm going to do plus and minus. I see 2x minus 3 is shared, numerator, denominator, so I can cancel. I get 4x plus 1 over 4x plus 3. 4x plus 1 and 4x plus 3 must stay. I cannot cancel my 4x's because I'd be canceling through addition, and that is not allowed. Let's do a few more. If I do problem 5, I'm going to look for GCF first. I see a 2. I'm going to take out the 2, and I get x squared plus xy minus 30y squared. In the bottom, I also have a 2. So I get x squared minus 6xy plus 5y squared. Now these 2's immediately drop out. Now these trinomials I'm going to factor. I'm going to use x and x. Factors of 30 that differ by 1 are positive 6y minus 5y. That'd be negative 30y squared, and get me xy in the middle. I'm going to use x and x. This means signs the same, so I know both minus. I'm going to do y and 5y, because that would give me minus 6xy in the middle. X minus 5y is the same, so it's going to cancel. And I get x plus 6y over x minus y. Remember, you can never cancel in the end through addition and subtraction, so you are finished. Problem 6, 4 terms. How do we factor 4 terms? We factor 4 terms by grouping. So I'm going to take this first one, and I'm going to reorganize my grouping. So I'm going to say y plus 2xy plus w plus 2xw over this one I'm going to do y plus 2xy minus w minus 2xw. Now you might be eager to start canceling, but you can't cancel before you factor, and we have not factored any of this. So you can't cancel those y's, and you can't cancel those 2xy's. You have to factor by grouping. I'm going to take this group and this group. I'm going to take out the y, and I'm going to get 1 plus 2x. I'm going to take out the w, and I'm going to get 1 plus 2x. Over, now I'm going to focus on this one and this one. So I'm going to take out the y and get 1 plus 2x. I'm going to take out the negative w. My signs are going to change to 1 plus 2x. Now remember, you're factoring by grouping, so you can't cancel anything yet because you're not finished factoring by grouping. Remember, factoring by grouping says group them, take what each group shares, and now find the common binomial to factor. So 1 plus 2x has to be factored. And I group together y plus w. Over, I'm going to do the same thing. I'm going to take out 1 plus 2x, and I'm going to group together y minus w. Now 1 plus 2x will cancel. And my answer is y plus w over y minus w. Let's try a couple more. 7. 7 seems pretty easy. All I see is GCFs. So I'm going to take out 7. I'm going to get x minus 3. I'm going to take out 21, and I'm going to get 3 minus x. So we need to talk about these right here. They're not identical because it's the opposite around subtraction. So we can't cancel them as being identical. But they are opposites. Anytime you have a binomial expression reversed around subtraction, you can see x minus 3 and then reverse 3 minus x, you have opposites. Opposites always cancel for a negative 1. So these cancel for negative 1. So we can cancel these, and I'm just going to write negative 1 in the top. Again, they're opposites because they are an expression reversed around subtraction. 7 over 21 reduces by 7, so I get 1 over 3. Remembering my negative, so I'm going to make my answer negative 1/3. Last one. Let's factor these. Top, GCF of 2, take it out. 2 times x squared minus 4x plus 4. Bottom, let's take out 4. We get 4 minus x squared. I'm going to factor my trinomial, and I'm going to factor this. This is a difference of squares. Remember, subtraction of perfect squares. So the top is x minus 2, x minus 2. The bottom, careful when you factor this, you want to get 4 first. So I'm going to start with 2's. So 2 and 2 plus x minus x. Now this right here, they're not identical, but look again, they are the reverse expression around subtraction, so they are opposites. And opposites cancel for a negative 1. I just always write it in the top. We also can say 2 goes here once and 2 goes here twice. So what's left in the top is x minus 2 over 2 times 2 plus x, and then the negative makes the whole fraction negative. So there is our simplified answer. So remember, if they ask you to write each rational expression in lowest terms, you're going to factor everything first and cancel to get to your simplified answer.